we need to find the domain of the following function, and we need to observe that these fx, it is actually square root of two different data separately added up. So when we are finding this kind of thing, we need to find it out the domain of the first function, domain of the second function. So if I am considering df1 is the domain of function 1, and that function 1 is basically root over of that part, domain of function 1, and domain of function 2, it is the second part. The union, the intersection of that will be actually domain of the function. Now domain of the function 1, so function 1, root over of that 1 plus x, 1 minus x. So 1 plus x, 1 minus x, whenever I am writing that root over of that, and I want to find it out, that it need to be positive. So I need to say that 1 plus x by 1 minus x need to be greater than 0. This entire data can be equal to 0, but this denominator cannot be. So here we need to consider that to attain this value greater than 0, positive value, I need to consider that number line, on number line. Acha, here it is given 1 minus x. So this, as it is 1 minus x, I can say that these one x minus 1, let me write, that means x plus 1 by x minus 1. If I write it, it should be less than 0. So x is equal to plus 1 and x equal to minus 1. These are the two data. If I am considering number line for finding the range of x, number line, it would be divided into three zones, and this is greater than, this is greater than, so this would be the zone which I need to find it out. Minus 1 to plus 1, this is the zone, that would be the range in this case. But can I attain this value 0, that means minus 1? If I am attending minus 1, it would be 0, it is okay. But if I am attending 1, it would not be okay. So for that zone, domain of the function 1, I need to write that it is belongs to x data from minus 1 to plus 1, but plus 1 excluding, minus 1 including. So minus 1 plus 1, it is excluding. It is the domain of the function 1. Now the same thing, I want to find it out, domain of the function 2. Want to find domain of the function 2, where function 2 is basically, root over of x plus 1 by x minus 2, x plus 2, x minus 2. Now to find this one, I need to know x plus 2 by x minus 2 need to be greater than equal to 0, but equal to 0 means this entire value would be greater than equal to 0, not the denominator. Like here it is greater than equal to 0, not the denominator. I am writing this one, but it is taking only one part. Okay, so to check this one again on number line, I am taking two data, one is value 2, another is value minus 2. Now here it cannot be attaining plus 2, but it is attaining minus 2. Due to that reason, I need to find it out the range. It should be plus 2 onward, plus 2 onward, and this one is minus 2 onward, minus 2 onward. This way, as it is greater than equal to 0, it has mentioned, but plus 2 excluding and minus 2 including. That means x belongs to plus 2 excluding. So 2, sorry, 2 excluding, and this is infinity excluding, union minus 2 including, but you minus infinity excluding. This way the domain of the second function. Now these two function, we have tried to give you this entire idea, but these two functions, if I am considering on the common line, I can see that minus 1 to 1, this is again another, minus 1 to 1 is again another zone for the earlier one. And if I take the earlier one, then I can find it out that it is earlier one is this range and this one is this range. That means there is no any overlapping. And if there is no any overlapping, so definitely it is defined no here. I can say that it is not at all defined, because if you want to make this one defined, what I have to do, I need to find it out. There must be some common df1 and df2 intersection need to be there, but it is no intersection, it is segregated, separated. So definitely define no here would be the answer of this question.